Welcome back students for another session on this video lecture. This is the fourth video of third chapter. This is in continuation of the three parts. As usual, you must go through the first three videos before going ahead with this fourth video to understand things easier. Getting back to this part, let me just say the things what you have learned in the previous chapter or something like this. You have learned position time graphs is what you have learned in the previous class, whereas three graphs I have shown you, of which two I am taking here. Clearly, one kind of a graph is a straight line passing through position and time called as uniform. If you remember, this is a uniform motion which is a straight line passing with certain slope. Where what is that slope of that line gives rise to? Slope of that line gives rise to velocity, which is obtained by using the tan of that. Now, to identify the slope, what is that we actually do? We can choose any two locations. At this line, slope is given. At this point, slope is given by theta. And at this point, slope is given by theta. At this point, slope is given by theta. At this point, slope is given by theta. Accordingly, or for a straight line passing through origin like this, slope is always constant. That's the reason why we say it is uniform motion, right? And this is what the slope is, and every time slope is obtained by taking two different locations. Change of that position is delta y and change of that time is delta t, ratio of these two. This is change of position by time gives rise to slope of a line of a body of uniform motion gives rise to velocity, and that in fact gives rise to what kind of velocity? Gives rise to average velocity. Total change of position by total time, from first initial position to final position, and total time gives rise to average velocity. Because body is in uniform, average velocity would be same at any location. Average velocity will be same at any point of time. But in real life, in practical life, is it possible to maintain this uniformity throughout the motion? For example, you are moving. If I say you are moving from your home to campus by traveling a displacement or a distance of 200 kilometers. In order to travel this 200 kilometers, can you maintain uniform throughout? You start with 0, you gain and keeps on changing. If you come by bus, what happens? It stops, it increases its speed, goes to maximum, maybe maintain constant for some time. Again, it has to stop in the next stop. Again 0, again increases, again maintain constant, again becomes 0. Keeps on changing, right? Even for trains also the same thing. In between two stops, it has to gain, it has to reach maximum. It again, before coming to a halt, before coming to stop, it has to reduce again. Accordingly, in real life or in practical life, maintaining uniform is not possible. Real life, you come across a situation where you are going to have non-uniform, and in case of non-uniform motion, this kind of a curved graphs you are going to get. Right? In the previous example also, I gave you what kind of these different locations in the syndicate. Now, what does the slope of this kind of a graph gives? If this graph gives slope velocity, then what this graph gives? Clearly, this slope is also giving rise to velocity only. But what kind of velocity that would be? What kind of velocity that cannot be now called as the average velocity throughout the motion? Because throughout the motion, you are going to have different types of velocities. We now introduce one more term called as instantaneous velocity. You are starting with some kind of zero velocity, gaining some velocity, reaching maximum, going at different locations. You are going to have different velocities. This term instantaneous velocity corresponds to that particular way wherein what is that velocity at one instant of time. If this is time, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. At 1 second, what is your velocity is? Means in between these two, we take this kind of line and we try to find the slope of that. That is change of position by change of time. And for some kind of a graph, slope is not going to be same throughout. Will be slope same or different? It is different throughout the location. See, slope same for all these lines? Clearly, for the entire line is slope same like this? Clearly, it is not same. It is different. Accordingly, in our real life, we do come across that kind of a motion which is non-uniform, which you are going to get some kind of a curved line or path like this. And for this kind of a line, slope is very difficult to understand. And to understand that, what important, but this is important, what important point it gives rise to is that it gives us a way to find out instantaneous velocity of any kind of a motion. When you're traveling, if you're starting at 10 and reaching Basar by 1 o'clock, in between 10 to 1, how many different speeds you have? At 10:10, what is your speed? At 10:20, what is your speed? At 10:30, what is your speed or velocity? Accordingly, that particular, at one particular instant of time throughout the motion, how much velocity the object possesses, that velocity is called as instantaneous velocity. We indicate that by means of V with subscript n, and I am indicating bar to show the concept of. And this is now actually going to give rise to one important term called as differentiation. Means how to identify the slope of this. Since at different locations it is going to have different slopes. At different locations it is going to have different slopes. We differentiate the entire part into very large number of small parts, such that each part would be having nearly a, no matter whatever the small part you take, that small part appears to be a straight line. Check out this one. It appears to be straight. It appears to be straight. Now, slope of this can be understood. Accordingly, by differentiating that into very large number of small part, each part corresponds to some different slope. I mean to say, slope of this part is different, slope of this part is different. Accordingly, for a non-uniform motion, you are going to have different kinds of slopes. Important thing about this different slopes is that it helps us in identifying the, now in our practical purpose, when you are traveling at one instant of time, how much velocity we have that called as instantaneous velocity. We can determine instantaneous velocity by using the slope of this kind of a graph. For that, we need to understand one important mathematical tool called as differentiation. By understanding this differentiation only, you can identify how much is the instant velocity possessed by an object at one particular instant of time. For example, let me say from here to here it is some kind of 50 minutes. At some time I want to talk about some 10 minutes gap, not the entire part. So what is that we do? We abruptly stop our journey there and we conclude the things present between 0 to that position. Right? That is what in mathematical way, in mathematical form, we write instantaneous velocity like this. In mathematically, you can write instantaneous velocity as that. We use a term called as delta t tends to 0. What is the meaning of delta time tending to 0? Delta t, change of time. Though journey is still continuing up to 50 minutes, I am just stopping that. I am concluding that journey at the end of 10 minutes. That delta t now is stopped after that 10 minutes. Accordingly, imaginarily I am saying that delta t tends to 0. Delta t tends to 0. This is called as applying limits. Out of my entire journey, I am applying some limits to stop that. That is what the mathematical form. Limit delta t tends to 0. And at that location, how much change of position you have? You have, if this is a 10th minute where I am stopping, from here to here there is some kind of change of position, delta x, delta y it is. And from here to here, this is what delta y is, this is what delta t is. Though the journey is still continuing, I am stopping here, that in the form of what? Applying limits at this location, wherein I am going to get a fraction or some kind of form. Instantaneous velocity is defined or given by mathematical formula. Instantaneous limit delta time tends to 0, delta y by delta t gives rise to some value. Delta y by delta t. I am applying limits onto this factor at some intermediate stage, neither at the starting location nor at the end location, applying some limits onto this entire part at some point where I wish to find out the instantaneous velocity. Applying like that is called as applying limits to this. That is delta t, applying limits onto the time such that I am stopping the time. Though we cannot stop, we say it is abruptly stopping there. Now finding out the ratios of position and time. For sure, this is going to give rise to some kind of a value, which would be now represented by means of dy by dt. This is what we say the equation for. This is called as differentiation of y with respect to time. You are differentiating the entire part, you're stopping there, and you are finding out its numerical value. Between two locations we get delta y. Between two locations we get delta t, and ratios of that gives rise to some kind of average factors. But at this location, how much you have is given by means of dy by dt. Now I can do the same part for one more region. Now from here to here again, applying limits at that location, finding out, you are going to get some other dy by dt value. Writing in this form is the thing what we call it as differentiating. Differentiating. And differentiation or continuation of that would be done in terms of integration. Differentiation and integrations are the mathematical tools which you will be learning in your higher classes actually, but physics we introduce them in the beginning stage itself. Now you should have some minimum knowledge on this differentiation before going ahead to this continuous chapter. Not only this chapter, when coming up chapter 4th, 5th, 6th and all, even that becomes easy. Those chapters will become easy only if you can understand what this differentiation means. Just simply remember these parts. Differentiation is means differentiating one kind of value into very large number of values. Dividing a bigger thing into very large number of small parts is called as differentiation. And because here the path is non-uniform, we are going to have different things. By applying this differentiation, you can actually determine the instantaneous velocity, which means that instant at one instant of time. I'm telling you, definitions are given, not to bother. Don't bother about the writing part. I'll give you all the notes. It is there. Understand the concepts. Differentiation is the important thing what you people has to understand. In the coming up in the continuation of this, I'm going to focus only on differentiation, and you can go ahead with differentiation only if you understand this concept thoroughly. Simple words, velocities are two forms: average velocity and instantaneous velocity. What is the difference? Average means total displacement traveled to the total time taken. Average means total displacement travel to the top of the total time taken. Then instantaneous, throughout the journey we are not going to have same velocity, but we are going to have various velocities at one instant of time. To represent that one instant of time, how much you have, we are using dy by dt, and this dy by dt depending on what, that time. Differentiating with respect to time. Which time it is? I'm tending the time to 0. I may tend this, I may stop at 10 minutes. At 10 minutes, how much value? At one instant of time, where I am stopping the time, that value is being shown. Delta y, delta t, change of final initial, clear. But this is at what time? 10 minutes I am stopping. This is with at the time t is equals to 10 seconds. dy by dt. dy by dt at 20 seconds. At time t is equals. Now we say when I write dy by dt, generally we write like this: dy by dt at a time t is equals to 5 seconds. Now what is this giving rise to? Differentiating y. Understand? Differentiating y with respect to time at t is equals to 5 is the meaning of that value. Hopefully that point is clear. dy by dt is differentiating. When you are differentiating, you will talk about one particular instant of time. Is there any one particular instant of time here? No, it is only final value minus initial value, final time minus initial time. Accordingly, you are going to get. So, hope that point is clear. Differentiation is important mathematical tool where we have certain formulas based on that. I am now trying to give you those formulas for differentiation purpose. You can go further only by knowing these formulas. What is formula for differentiation is that we always say d by dt, or differentiating with respect to time is d by dt. If you come across d by dx, it is called as differentiation with respect to x. Differentiating with respect to x. Let me pause a while to erase this board. Right, check out this. Differentiation is a mathematical tool which is used to solve many numerical problems, either in maths or in physics. We make use of that mathematical tool to solve the various parts what is needed with respect to us. Differentiation involved with certain parameters. All physical things are parameter. Velocity is a parameter, physical parameter. Velocity, acceleration, displacement, all these are different parameters. These parameters can be of two kinds, constants and variables. What is a constant parameter? Any kind of a number, 2, 3, 10, 15, all any kind of a number is always constant. 2 is always constant. No matter wherever you go in the inverse, 2 is always constant. Whereas what are variables? Parameters can be of two different kinds, constants and variables. What are variables now? Variables are those which keeps on changing. What is my variable? Which keeps on changing. Again, variables are of, parameters are of two kinds, constants and variables. Constant remains forever, same forever. Variables which keeps on changing, basic things. Again, variables are of two kinds, called as dependent variables, independent variables. How to understand what is a dependent variable and what is an independent variable? I'll take one example of velocity to make you understand that. Velocity is defined as displacement by time. Velocity is depending on what? One parameter called as displacement. But this displacement keeps on changing with respect to what? Displacement keeps on changing with respect to time. Here there are two things which are deciding what velocity is. Velocity is depending on two things, that is in the form of displacement and time. But here clearly time is not in our hands, it keeps on moving. Either if you say yes or no, it keeps on changing. Therefore time would come under what thing? Time is an independent variable. It is not depending on anything, it is depending on itself, which keeps on changing. Whereas velocity is depending on what factors? Displacement. Now you can say displacement is, and if displacement is dependent variable, accordingly velocity will also comes out to be what? Dependent variable. Velocity is depending on what? Well, displacement. Displacement is depending upon what? Change of position. But these are not depending on what? These are not depending upon the time. Time will keeps on moving. Time will not stop or will not wait for anyone accordingly. That is the meaning of variables are of two kinds, called as independent and dependent variables. Time is an independent variable which keeps on moving, not dependent on anything. Whereas since velocity is depending on displacement, now we make use of this basic definition. Velocity is displacement by time divided by dt is finite changes square. By applying limits onto this finite values, you are going to get the differential values in the form of dy by dt. Writing like this is what we call it as differentiating. Differentiating of displacement with respect to time, d by dt. We say that we write this like this, d by dt of, what is y actually talking about? Change of position. In other terms, it is talking about what? Displacement. Differentiating displacement with respect to time gives rise to velocity. Differentiating displacement, displacement, differentiating displacement with respect to the change of time interval gives rise to velocity. Now, with respect to this differentiation, there are certain important formulas. I'll just write up all the formulas what are needed for this context in this chapter or coming ahead chapters. And let me try to give you as many formulas as possible. These formulas you should remember as it is. And more about this differentiations will be coming across in your mathematics second year. Differentiations and integral. Probably I may feel that you may also need given introduction for integrations also. If needed, I'll do that also in the next video. Let us first focus on differentiations. Important formulas. First one, d by dx. Let me say I have an equation in the form of y is equals to x. Differentiating of one parameter with respect to x. If you differentiate any constant number with respect to some x, differentiation of constant with respect to x gives rise to 0. One formula. Next, second one, d by dx of the same number gives rise to 1. Formula. Differentiation of x with respect to x gives rise to 1. Third important formula. From third formula you can drag all the formulas. D by dx, differentiation of x to the power of n. Differentiation of x to the power of n. Formula for this is n into x to the power of n minus 1. If you know this, you can write some other formulas also. Now, fourth one. What is d by dx of x square? Same method both are, right? D by dx of x square is equals to what? Use this formula. In place of x you have x. This is the formula to get the answer. And in place of n, what is that you have? You have 2. So accordingly this becomes what? 2 into x to the power of 2 minus 1. This is equals to what? 2x. Differentiation of x square is equals to 2x. Can you write for x cube now? Only extension. D by dx of x cube. Again 3 into x to the power of 3 minus 1. Gives rise to what? 3x square. I am writing formulas like this. Important formulas. Now we cannot do anything like if you are not knowing these formulas because these are mathematical tools, but formula should remember d by dx of differentiating some constant number with respect to some variable. Differentiation of constant with respect to variable, you are going to get 0. D by d differentiation of x with respect to the same thing is called as 1, dx by dx. It's not that we cancel dd. Dx is one single term, right? Dt is one single term, that is change of differential value. That is d by dx of x. This is important formula. D by dx of x to the power of n. D by dx of x to the power of n. N into formula. Remember like that as it is. N into x to the power of n minus 1. By applying that formula, I have written some formulas. Now, sixth one. D by dx of e to the power of x. Will get the same thing. Differentiation of e to the power of x gives rise to e to the power of x itself. Differentiation of log x to base e gives rise to 1 by x. You can solve also these things, but that is not the purpose. We should know the formulas, right? Accordingly, we are not going like that. D by dx of sin x gives rise to cos x. Differentiation of sine with respect to x. 9. D by dx of cos x. For all c terms, you are going to get a negative sign. For all c terms, you will get a negative sign. If it is cot x, minus something. Only sine, cos or cot. For both of this, you are going to get a negative signs like this. Right? Next, 10th one. Right, I have added some more formulas that sine is differentiation of sine with respect to x is cos x. Differentiation of cos with respect to x is minus sin x. All c terms will give rise to negative sign, negative answers. Remember that c will give rise to minus. But what upon practice you will get this. D by dx of tan x is secant square x. Formula it is. Remember that. D by dx is cot x is minus cosecant square x. Differentiation formulas these are. D by dx of cot this is. D by dx of secant x is tan x and secant x. D by dx of cosecant square x is what? Minus cot x, secant x. And I urge you people to learn these formulas, and these formulas are the one that are present in the textbook, page number 65. Those who have Telugu Academy textbooks can refer this page to understand these formulas. Next formula is called as product rule. What it is called as product rule means if you have two things in the form of product form, how to get that? If question would be something like if y is equals to u into v, u is some number, v is some number, then how to take this? Differentiating with respect to y means dy by dx is equals to u into dv by dx plus v into du by dx. You have to separately differentiate the things. First differentiate, keep u as it is, differentiate v if there are product of two numbers. Then plus to that add what that, keep the second one constant, differentiate first. These are the formulas. I think you cannot see if I write there, so I'll write up somewhere here. Okay. After that formulas, I get is 14 in number there. I'll write 15 formula here. 15 formula that is called as division rule. If you have product rule, you get division rule also, right? U by v. That is, if y is equals to u by v, then what it is? dy by dx is equals to differentiating y with respect to. First, you should do differentiation of the top, then you should do the differentiation of the numerator. It is something like this. It is first you are going to get the square of the denominator. Formula it is, you have to remember, that is v square. That is differentiation of top means what? Du by dx. keep top differentiation first, multiplied with this one, minus the remaining part, keep u as it is, dv by dx. Formula for differentiation of division rule. This is a formula of differentiation for product rule. You should remember these formulas. These are being taken from page number. These are being taken from page number 65. You can multiply this. One more easier thing is that if you have differentiation of dy by dx of some constant multiplied by x, if you have differentiation of this one, constant will always comes out of this k into dx by dx, giving rise to what? K into 1. So this is now going to have what value with that? K. Differentiation of some constant multiplied by x gives rise to this one. So you should be well versed with these formulas. Some more are there, maybe there, but these are the minimum things what we should know before going further. Now what I'll do is, whether to understand whether you have learned or not, I'm going to give you one or two examples, and let us check with one example how we use this differentiation to find instantaneous velocity. Let us use this one with an example to find out how to use. You should be well versed with these formulas. Once the formulas are clear, you can now apply these formulas of differentiation to find out instantaneous velocity. Now I'm going to take one example of how to find instantaneous velocity. Let me pause for a while. So here is the question to identify whether how can we apply the concept of differentiation to identify the concept of instantaneous velocities. Question is something like example 1. The displacement of an object is given by change of position is given by y is equals to 4t square minus 3t plus 6. Random example I have taken. Find its velocity at t is equals to 2 seconds, 3 seconds. These are three different questions. At a time t, that means at this instant of time, how much is the velocity? At this instant of time, how much is the velocity? At this instant of time, how much is the velocity? So we want to find this here. So let us see the solution how to do this. First, write the given equation y is equals to 4t square minus 3t plus 6. To identify the speed from position, what is it? If this is displacement, how to get speed from that or velocity from that? Velocity is given by rate of change of displacement. Means what is that you have to do to get one instant? Differentiate this equation with respect to time. Means write like this: differentiating above equation with respect to time. Formulas are written for differentiating with respect to x, but here the parameter t square is a variable here. Here the parameter is time. Parameter which is undergoing a change is what? Y is depending on t. T is variable, right? Accordingly, differentiating this equation. How do we write differentiation of that equation? dy by dt. Differentiation means you should write d by dt for this factor. Differentiation means you should apply this d by dt. Of what? D by dt, what you need to apply? For time. And when you are applying this, what is it you are going to get? We said differentiation with respect to time gives us instantaneous velocity. V instantaneous, giving rise to. Now, d by dt of, what is actually y means? Write that equation. 4t square minus 3t plus 6. Now, you need to apply differentiation with respect to for each of this parameter within the bracket. To make that understand simply, what we'll do that initially we apply that for separate terms. You can write it as 4t square term, d by dt of 4t square minus d by dt of 3t. I have taken minus outside. Or to avoid confusion, first let us insert this inside, later we will take that. Plus of minus 3t plus d by dt of 6. We are first applying differentiation to each of this term like this. Each of this term, d by dt of this term plus d by dt of minus 3t term plus d by dt of 6. Now we should make use of those formulas what you have learned to understand that. Now we said that if you have d by dt of 4t square, 4 is constant which comes out of this. That is 4 times of d by dt of t square. Can you write? I'll take minus out of minus comes out of this, that is plus into minus gives us to minus. 3 is also constant, can be taken out of this one. D by dt of t minus 3 is taken out of this one, remaining term is d by dt of t. No terms is coming out, it is simply in the form of d by, I'm keeping this sign number asterisk, this term parameter asterisk, d by dt of 6. Now can you apply formulas clearly? Let us go back to this. D by dt of C is constant, d by dt of constant is 0. Refer the formulas. This is the form of d by dt of x to the power of n. D by dt of x to the power of n. What is that x to the power of n formula? D by dt n into x to the power of n minus 1. You should know these formulas before going. 4 into, what term remains now? 2 into x is t, n to the power of n, x to the power of n minus 1. Can I write like this? Check your formulas and check out. Right, you can write like this. Minus 3 would be as is. D by dt of t, can I put that as 1? Check your formulas and tell that. This is the entire part. Now continuation. What are you going to get? I think you cannot see if I write down. I'll write here. That is V instantaneous is equals to d by dt is equals to, what is that you have got for d by dt now? 2t t to the power of 2 minus 1, t to the power of 1, 2 into t to the power of t1. That is 4 times of 2 into t. Can I write? Minus 3. Since it is plus 0, let us ignore that. Or that is V instantaneous is equals to dy by dt is equals to 8t minus 3. So if you differentiate this equation, you are going to get 8t minus 3. Because this is the first problem, we are doing so many number of steps. By thorough practice, you must be in a position to do that by your own. Right. Now at what time we want? We want dy by dt. At what time we want it t is equals to 2? dy by dt at t is equals to 2. What is it you are supposed to do now? This is first one. You are supposed to substitute t minus 3, which is equals to what? 16. 16 minus 3? 13. What would be the units for this? Meters per second. In this kind of problems, you will be specified all the terms in there expressed in terms of units. Meters, this y is expressed in terms of meters, and time is in that question. In question, he would be specifying the units, because in the first example I have not taken that, and time is in terms of, you say 8 to the 16, 16 minus 3 is 13 minutes. At a time of t is equals to 2 seconds, velocity of this object undergoing is in the form of 13 minutes. Now at that instant we got. Now check out for second instant that dy by dt at a time t is equals to 3 is given by, now in place of t, what you are supposed to do? You are supposed to substitute 3 minus 3 giving rise to 24 minus 3 giving rise to what? 21 meters per second. And third one, at a time of t is equals to 4 seconds, we write that dy by dt at a time of t is equals to 4 seconds is equals to 8 into 4 minus 3, 8 4 is 32 minus 3, 29 meters per second. Now this is the thing what we say instantaneous. At the end of 2 seconds his velocity is 13. At the end of 3 seconds velocity is 21 meters per second. 4 seconds 21 meters per second. This is the way how we apply the formula of differentiation to understand the concept of what? Instantaneous velocities. Very important thing, you must understand this. Without understanding this, no further going. You cannot go further. It's a customary thing on everyone to make sure that you are following this. I'll give one more example to for you as a practice. I'm giving you one more example for you as a practice. I'll be just verify. I'll keep this asterisk. I'll just change this numbers here. State example. The displacement example 2. This is the displacement of a particle is given by y is equal. So here is example 2, which can be solved in the previous way itself. So you can make a note of this question and try to solve it and try to give your answers in that. Right? Try to submit your answers as per your comfortability. I just want to find out. I want answers for dy by dt at t is equals to 4 seconds is how much, and what is the answer for dy by dt at t is equals to 5 seconds. This is equals to how much? I wish you people to go through this previous solution thoroughly. Make sure that you are understanding that. Of course, I'm sure that maybe just by that looking at that video you may not get that, but you should understand that by keeping that video in the pause mode. Pause it, listen, pause it, listen, repeat it, repeat that videos as many number of times as you can, but till you make sure that you are understanding that. Once you understand that, things becomes very easy. If you want, I can provide solution for this, but I wish you people to make an attempt from your side first. Make an attempt from your side, see that you're getting that, and I'll get back to you with one more session in the next video, that is part 5. And not only this, I wish everyone, the physics, understanding physics needs a thorough revision. Just by listening to videos, keeping books aside, nothing you'll get. You should focus continuously on the things what you're learning, and especially that should be done on a daily basis. If you do it before exams or just you get time and all, that is not sufficient. You should always do physics works at a regular manner. Hopefully you are getting these points and all. We want you to convert yourself into the best citizens. For that we are ready to help you. Only thing is that you focus, listen, concentrate, learn, and then get back to us if you need any kind of more assistances. Till I catch you for the next time. All of you stay safe, happy learning. See you soon. Thank you.